So welcome to Herding Velociraptors, which is our Velociraptor workshop. So first of all, a little bit about me. My name is Matt. I work in the DFIR team at Rapid7. My background is very kind of endpoint and threat focused, and been doing IRE stuff across an EDR vendor, across consultancy and all that stuff. And actually that's kind of how I started using Velociraptor. Is I was at an EDR vendor and I needed kind of an IR tool or a serious kind of forensic tool. And I started using Velociraptor about 4 years ago. A lot of the content that I've added to the platform has been practical stuff that I've used in field, and I just wanted to contribute back to the community, really. So the agenda for today, we're going to talk a little bit about the background to Velociraptor. I'm going to walk through and install for detection work. And this is actually my setup, so hopefully you'll get some value out of it if you want to use Velociraptor. And then I've got a few kind of use cases to work through that cover things like disk, memory, some Yara, as well as some monitoring. The last one, monitoring, I might leave off. We'll see how we go for time, but I'll share kind of a resource that will have a whole bunch of other use cases that you can test out and walk through if you're interested as well. The goal of all this will be to cover kind of practical use of Velociraptor, and hopefully you'll get value from a detection viewpoint as well. The prerequisites, you'll need a VM to run a lot of the tests and things. You'll also need MS Build as a prerequisite. So .NET version 4 you'll need installed, and there's a link there. The latest Velociraptor will be available from GitHub, so you'll need access to the internet. And I'm going to share like a text file with links and instructions on the Velociraptor server itself. So hopefully doing like labs and things will be fairly pain-free for people. You can always ping me and reach out to Matt Green on Slack if you need assistance or need help with anything. So first of all, what is Velociraptor? Velociraptor is an open source DFIR tool, and the use cases that we cover are things like incident response, forensics, as well as monitoring. It was founded by Mike Cohen, and most people know Mike from the Volatility Project or GUI. And actually that's a lot of the kind of the source and a lot of the background for Velociraptor. It came from a port of GUI. Essentially, it was created kind of from the ground up to fill in a lot of the gaps that GUI had, which GUI was designed for Google, coming from scale down. It didn't fit so well. Probably the biggest claim to fame in Velociraptor is it's a single binary written in Go. And that binary has the server components, it has the client components. It's just a single kind of like engine for running a query language. It's really awesome when you get to know it. Because of that, the support covers pretty much anything that Golang supports. So Windows, Mac, Linux, and exotics. There are some caveats there. If you're a consultant and you're looking for like a 2003 compatible tool, Velociraptor is Golang, so you'll need to make sure that Golang is supported by your target host. Okay, so the other claim to fame for Velociraptor is its simple architecture. I touched on before it's query language driven, and we'll get into that a little bit later. But the whole purpose is to simplify DFIR at scale. You can literally see three components there: server, client, and user, in terms of what's required. We do have more advanced setups, but that's a little bit out of scope for a detection discussion, but there is documentation if you want to go up to, say, 200,000 endpoints, like the last point here. My general setups are single server with a file-based data store, and that will cover you up to maybe 15. I've even gone up to 20,000 endpoints doing that, but you can read the specs here, and it works extremely well for an incident response use case of deploying the agents, doing your IR, then whacking it down. It takes a little bit more effort and management to do things like update and manage the data store if you're going to use it in like a permanent deployment setup. So this slide is extremely important, and it kicks off on where I think the most value comes from Velociraptor, and that is access to data. Velociraptor provides access to all the important things that you need access to on the endpoint. So things like volatile data, memory, things like static data, so your traditional forensic artifacts, as well as that telemetry. Velociraptor uses a concept called accesses. So when you're writing a query, you can set the accessor to, say, process for access to process memory. You can set the accessor to NTFS to give you access to the NTFS file system, that kind of stuff. It's really simple to give you access to the things that you need. We also generate rows in the system by using plugins, and those plugins could be, say, a glob plugin for pulling back like file and path information, or it could be a plugin that is like a forensic artifact like prefetch that pulls back past prefetch rows. The whole idea here is we can also do things like data manipulation by using functions. So with the example I gave before, you might say use a glob plugin that pulls back paths, and then you might have a hash function or a parse PE function to pull additional context out of that path. We also have the filter condition, which most people will be familiar with if you've used like a query language that's kind of SQL-like, and there's lots of them out there. There's other workshops on that stuff. So that's pretty straightforward. And this is the workflow that I kind of follow. So I use Velociraptor to collect things and find rows, and then I can ask more questions and pivot from there. My collection might also be like a raw artifact collection for preservation. So we've got some content that's specifically designed. We actually grab Cape files from Eric Zimmerman, some of the path location there, and we replicate that in Velociraptor. So we can do preservation based on the Cape locations, which is pretty awesome. We also can do analysis. So not only targeting your collections to be very precise, you can also collect loosely and pull it back to the server, and then use like a notebook feature we have to further do analysis and extract the information that you'd like. I've also listed secondary platforms here. A lot of users, and we actually use TimeSketch internally, but a lot of users will also send to Elastic or Splunk or whatever your poison is. You can send your collections there for analysis too. But the big power to having a live agent is the last point, and that's pivot and repeat. It's so powerful during an incident response to be able to query for something, have results, and then query again in a matter of minutes. It's really awesome, and hopefully you'll see some of the value in some of the workshop items that we run. For more learning, this slide is really important because it's got links to GitHub, documentation and training, as well as our community site. That docs page in the middle, I think, is probably the most important because it has all the training and all the artifacts, and essentially it's a search area. But also the present page at the bottom will have a list to a lot of our updated training materials in a modular way as we move forward. So make sure you bookmark that one as well. So next up, I'm going to give a demo of the installation and a brief GUI tour. The page that we're after is raptor.deathcon.local at port 8889. The login will be the same as your DEATHcon Windows network login, and it should give you access to the Velociraptor server. First of all, once you hit the server, you'll see like a nice kind of landing page like this, and you'll see some links to get you to various sections. At the bottom is a link to some lab files that I've created that will be a share that we'll use a little bit later when we do the labs and the install. But for now, I'll get you to click on this kind of hamburger that has like a menu. If we click on the home, you'll see the home screen, which is kind of like a server status screen. This spot essentially gives you status of the server. So CPU, currently connected clients, there's only a handful now, so this isn't a pretty graph. This is all configurable, and you can kind of see things like disk space, users, and server version information can be pulled from here, but you can put whatever you want. And it goes to that theme of VQL being configurable and being available across the whole system. Down the side, we've also got various kind of features that we'll walk through later, but probably the big kind of use case that you'll be working on is how do I find a client? I can click the search bar and it will bring up all my list of clients, or we can do things like search for a client here. And you'll notice we've got kind of autocomplete to find things easily. You can also do stuff like wildcards. It's kind of straightforward. We can also use things like labels, and I'll just add a label to kind of show how we can find machines using labels. And if you have a look, we've got hosts there, but we can turn label and maybe type in Matt. And again, autocomplete finds the host that I'm interested in, which is kind of useful. This is the kind of client landing page, and you can see things like client information, last seen, and all of these are fields inside the kind of clients table that we can query and build like server-based queries on. Of note is this client metadata, and there's nothing here now, and most people watching this probably won't use that, but I've used and I've seen used things like incident response workflow by setting this metadata. Like, for example, you can build some workflow on, like, maybe set your like analyst name and what the state of the machine is. If you're looking at doing some kind of triage on it, you can set it as maybe a status of compromise if there's further actions to take from an automation viewpoint. It's really up to kind of people who are using the platform and what they want to do. There's lots of capabilities that you can run. The first thing I'll point out is this bar along the top where we have, you can see we can add a label, we can add things like quarantine there, which is kind of handy. On the right-hand side, we've got some features that require the overview is this screen, but this here is shell. That gives you kind of like a shell on the endpoint. Now, it's worthy to note that you do need to have Velociraptor administration privileges to run this. So a lot of the users won't have that until I show you how to run it locally and test the feature out there. But I've just put a command and you'll see it will go out and essentially run this PowerShell and then return results. So exactly like you're running PowerShell on the endpoint, we have the ability to shell out. And this is super useful from an IR perspective where your tools may suck, to be able to shell out and run things, or if you don't know about content, it's super handy to be able to do that in the field. We've also got this collected screen, and you can see after running that PowerShell command, I've actually got a flow or a query here, and you can see details on the collection that was ran. The flow ID, who ran it, kind of start times, how long it took, all of that stuff. And we'll get into this a little bit deeper later, but you've got things like the results panel, and this is exactly what we were seeing before is the results. It's just not pars with standard out, the log, and we'll get to notebook a bit later. So that idea of everything that we do and everything that we see is just a VQL query is super powerful, and it's one that I'll keep iterating as I go through this demo, so you can understand and get it drilled into your mind that like you're not really limited to doing anything. It's just a VQL query in the platform. So going back to the main view, the next thing I wanted to show was VFS. And VFS stands for Virtual File System. It's very similar to the GUI feature, and it works the same way in terms of running a query on the endpoint. What I'm drilling down to is auto, which is file system. So on Windows machine, this is using the Windows API. On Linux, it's using the Linux file system. You can also see NTFS underneath, which is using our NTFS accessor and accessing like NTFS files. But as I drill in, I'll see if I can find a file to grab. I'm IE user. We've got your typical folder structure to traverse. So you can hit this R button to recursively grab every file, but I like doing singly, so it's a bit snappy. And here is the config file for this environment, and we'll collect it from the endpoint. A feature that's handy in IR is to be able to drill in like this and maybe look at the text view, maybe look at the hex view, right, which is kind of cool, as well as having relevant timestamps. And this is the same with NTFS. If I drill into this, you'll get pretty much the same view, but you'll have NTFS timestamps. You'll have things like Windows special files that you may not necessarily see with the API. You can kind of see here. So essentially what we're doing is we're using Velociraptor's NTFS accessor here to see its representation of the disk. So kind of handy. Similarly with registry, you can drill in and view the registry in the same kind of way. Go to local machine. If I can click local machine. And you can see this is a string entry, the value is 6, and so on and so forth. Like, there's nothing special with what we're doing. All we're doing is kind of putting into a graphical way how Velociraptor sees registry entries. I'm going back to this collected screen. You can see, again, everything is VQL here. We've got these list directory collections that ran, and we've got the results that we saw there, along with logs available to us. The next section I want to show is the concept of artifacts. And this is essentially the view of all the artifacts on the system. An artifact is a store of VQL that you can run either on the server, on the client, or like as a monitoring query. What we can do is use this search bar to search for kind of keywords we're interested in. And I've searched for task here. And let me just increase the size a little bit. But what this will do is it will search for all the artifact names and also in the description of the artifact as well. And what I'm interested in maybe is task scheduler information. When I click on that, I receive the artifact listed in an easy to read way. And if you watch, if you follow Wes from Security Onion on Twitter, he's been releasing artifacts of autumn recently. And this is what he's screen capping, and it's pretty easy to understand what the artifact does when you look at it with this view. You've got your description, you've got your parameters, and then you've got your VQL at the bottom. Now, this is actually a good artifact to go over because we've got 3 separate areas, and it really helps highlight how VQL works. In this first section, we're kind of naming the section uploads, and we're using the glob plugin to extract rows. We're extracting the fields from this, name and full path. And then if the condition upload is set, so if you have a look, we've got a parameter called also upload, we'll then upload the file using full path. So if you remember what I was talking about when I was talking about being able to do enrichment, this is a really good example. Down here, we've got another section called parse task. And here we're simply reading that full path and parsing out the task XML. Finally, we've got the presentation VQL section where we're selecting from each row in upload, so from this glob, and then we're having a query of parsing the task, and we're presenting that data. And this is a really easy way to do some nice parsing, and it's really simple compared to other query languages, I think, to get a nice presentation. What I'll do now is I'll show the concept of hunting. And I showed a query run direct on the machine from the machine view previously, but say we want to run this across many hunts. All right, let's run the same collection we ran before. In this case, I'm just going to call it tasks. We have the option to maybe target a label or target an OS or target whatever we want. But in this case, I'll target me because I made this label before. We'll select our artifact. Let's run tasks. Task scheduler. And let's configure to upload. Of course, you can change your path if you're running like having different interests in targeting somewhere else. And this is actually my big value add to the project that I have done, is that a lot of the artifacts that I've added, I try to make it easy for the user to kind of work, and I try to add useful filters and useful capabilities in various things to help with workflow. Otherwise, and you'll probably find this when you're working on your own content, you need to kind of hard code it in. You need to copy pasta kind of existing artifacts, and it can be a pain. Making artifacts generic enough to reuse in a whole bunch of different use cases is a really unique challenge, and it's kind of fun to do, to reuse. Here we have our resource limits, and this is important if you're doing stuff like Yara or doing something really heavily intensive. Yara on the disk, that is. Things like max execution time, a default of 10 minutes is built in, default of 1 million rows or 1 gig. That's huge. You hardly ever hit that. These are more built in to kind of stop you from DOSing yourself accidentally. In this case, this is a pretty straightforward query, so we don't really need to do much more than that. When we run the hunt, it's automatically set to pause. But if I hit play, we'll go off and run that. Because we're running a hunt, I can drill into the machine itself, and you can kind of see we have total scheduled one finished, and it has information. You can pivot through these views and get information on the hunt as well. But the thing I wanted to point out across all of our features is this notebook feature. If you remember, I talked about being able to kind of use a Jupyter notebook type feature. This is it. So this is attached to the hunt. Say I've queried 1,000 machines, I can then use this feature to kind of do things like data stacking. It's not going to work too well when I've just run it against one machine, but say I have a name that I'm interested in, and I say evil, I can do my filtering and find a task or things like data stacking to hunt effectively. So this is cool, really simple to use, and it's kind of fast and effective. When I go back to my client, you can kind of see it's run the hunt here. The notebook is not configured for this one because this is the collection inside the hunt. When we look at the results, it's exactly the same. You've got your logging here, so you can see what's happened, how many rows. And the other cool thing is you've got the uploaded files here. So say you're interested in uploading a binary or uploading something, you can come here and hit download and download it locally for further analysis if you like. Okay, so next up, we're going to do the first lab I have. And to get to the instructions, you click on the Velociraptor icon and down to the link at the bottom that I referenced before. Or alternatively, you can just type in files as a link to the main Velociraptor UI. Here we have a list of files to download, as well as setup instructions. I've already downloaded the details, so we're just installing the MSI. One thing to note is when you download the link files, if you're using Chrome like I did, you'll need to rename them .lnk because Chrome doesn't like you downloading link files. You didn't then copy I like to copy the link files to my desktop for ease of access. Once Velociraptor is installed, we then stop the Velociraptor service. hit stop, and then set it to disabled. And the idea here is when we want to run the Velociraptor client mode or in local mode, we'll just load those link files up. So once that's done, I can then jump to the C program files. And this is where Velociraptor is installed in the Velociraptor folder. What we're doing is we're copying the config file here. And I'll just open that up and show you. It's just got the kind of the server details for the client, public cert, as well as temp folder and configuration information. This is used for when you're running client server mode, so it knows where to connect that to. For GUI mode, just need to create that folder. GUI. And then we can run the link file. And it will kick off local GUI mode. These links are set to run as admin. So they've got required privileges to access various parts of the disks that you'd expect for forensics. And what you can see here is, if you remember when I did the GUI walkthrough, I talked about it being an all-in-one binary. And that's what we're benefiting from here. You can see we've got localhost. Essentially, GUI mode is loading up the server component. And in this GUI folder, we've got all of our server config. The reason why I do it this way is so your kind of development work is persistent. If you don't configure the local data store that I do in the links that I've shared, it will kind of push default the data store to see Windows temp. And it works, but the problem is you find every now and then your work may be deleted as Windows temp is flush. So I really like it this way. So it's a permanent install. Before I jump into showing some of the capabilities of GUI mode, we can run server client mode and it runs exactly the same way. I just like doing things this way so I can troubleshoot and see this kind of verbose mode output as I work. And then you can see the results. You can see maybe if your query is heavy load and how long it's going and all of that good stuff when you're doing artifact development. Back to the GUI mode. It's exactly the same as what I demoed before, right? So the main difference is we've only got one client, and that is our host. You've got that collected view where you can run kind of artifacts. You've got the hunt view where you can run hunts and test hunts. The artifact view. The only thing I'd recommend running here is importing the exchange. And the artifact exchange is kind of like our community repository. So there's a whole bunch of interesting artifacts here that will help you kind of get examples of copy paste, examples that you can copy and paste when you're writing your own artifacts, and other useful things that you might want to call when you're playing around in your machine. Probably the big section that you'll be working a lot in is the notebook. And I'm going to call this development. You can share it with all users if you're on the server. Not so relevant here. We've only got one user. But when I create this section, we now have a section where we can mess with VQL and start writing queries. So maybe let's start with see where. So I'm just going to write a glob here, and then we'll use globs. You can see it's kind of auto-completing. This is the main benefit of using GUI mode, is that we've got built-in help. And I've been using the platform for 4 years, and I still can't remember what all of the parameters are for various plugins and functions. So this makes it really easy to do development. And if I hit star there, I need to escape this. One thing that you'll find in Velociraptor is the need to escape. So basically with standard quotation marks, we can escape like that. Another feature is this triple quotation marks, and that gives you the need to not need to escape, which is useful. If you're using regex, you'll need to escape regex, and this is probably one of the most confusing points for new users, where you might need to double escape if you're using regex. But for this particular use case, say we're interested in name, OS path, and we might want to put a filter on where name equals maybe ends in exe. And this is regex, so we can do that, right? And then what we'll do is we'll limit to the Velociraptor binary. Then we might want to enrich this guy, right? So let's make it a bit nicer. And maybe let's look at a hash. Path. Have a look what other options there are. We've got hash select. Let's just get SHA-1. SHA-1. And then we'll call it SHA-1. We can also do things like parse PE. Info. So you can kind of see what I'm doing here. It's pretty straightforward. This is a real simple query. I haven't added a comma. And this is probably the other big learning point you'll find is you'll accidentally have parsing issues, and then you'll need to read the error and figure out kind of what you've missed. In this case, it was easy. It was just a comma. What have I done wrong? There's no SHA. So let's go back. Oh, I see. Right, so it's about working your way through the algorithm, so through the query, and figuring out what you've missed, what you're interested in adding, and it's just about kind of working your way into a query, just like coding, really. OS path as SHA-1, right? So really, the VQL writing side is easy, and that's the whole point of this fast feedback loop. For example, you've seen me mess with this query that I'm interested in writing here, and I'm able to iterate very fast. If I was to run a query on the server, there'd be like a 30-second, a minute feedback loop each time I run this, and it would take a lot longer to write content. That's pretty much all I had to show here, and I guess we'll get into it on the next lab. Thank you.